said, the mineral can be divided in two parts, port and starboard. Two robot units identical in functions and 99% equal in shape. Each part, you are seeing each part of the mineral. It's an integrated one. Each robot unit has two pickup devices, two tracks, and one discharging pump, so that it can be operated individually. Why? The 5 meter wide width large robots cannot be easily transported on road. So that we have cut, and we have thought that if we attach the unit modules in such a way, the mining capacity can be easily expanded to the commercial scale. So we have tested collecting or pickup efficiency in the laboratory. We have varied the gap. Design parameters gap is a clearance between pickup head and seafloor. Of course, this gap can be controlled by using hydraulic cylinder, nozzle shape for hydraulic system, and flow rates for water pump, and so on. In the laboratory, maximum 95% of collecting efficiency has been verified. Yeah, because of this gap of two pickup devices, 100% pickup was not principally possible. And as C test, we tried twice at water depth of 130 meters in 2012 and 2013. Before the sea test, we have prepared the sea floor with artificial nodules. Which is very similar, is simulated in strength and size and specific weight together. You will videos for the recovering of the robots from the sea and opening the gate, the door of the beam to let the nodules fall down on the board to calculate how much nodules were collected and so on. I prepared three or more video clips to show you. You are unlucky, not me. Yeah. We had to have very precise underwater localization system. As you see here, we are all using navigation system for our cars. Depending on the devices, the accuracy is different. I cannot select so much navigations in my one car. Tae is a specialist of this localization algorithm. Before we are going to the mineral path tracking test, the localization system is prerequisite step. not only using the underwater sonar system, but also the dead reckoning sensor data are merged together to enhance the accuracy of the localization. As we all know, the underwater acoustic wave is elastic wave, so that the random noise is inevitable. We have to always work together with this random noise to get accurate position. Such a sensor fusion algorithm is quite important. Based on the underwater localization system, we have performed steering characteristics investigation of the developed mineral on the soft seafloor very thoroughly. Yes, and this slide shows the trajectories path of the mineral. The performance parameters are falling speed, angular velocity at steering, track speed, sling angle, etc. I will go faster. Next topic is aerial coverage performance. As mentioned by Ted the first day, as a lawn mower, you can compare vacuum cleaner and vacuum cleaner robot. Vacuum cleaner, you have to move the cleaner to the position of where the dust and waste are there. But vacuum cleaner robot moves himself and sweep whole area automatically. That's the difference. The automatic path tracking of mine robot is ultimately important for profitable mining of the telemetry modules. We conducted 2 times. Can you recognize what does mean this path? This is mineral. This is generated by mineral itself in the depth of 1,370 meters. I would like to show this video, however, that this computer does not work matched together. Originally, we wanted to do all kinds of path tracking tests in the depth of 1,370 meters, but as you see here, the undulation of the seafloor was very, very irregular and large in magnitude. And further on, because of the size of the ship was only 70 meters long, so that only 1 meter height wave was very serious. Therefore, we could not stay there long time. We came back to the shallow water region to do this precise path tracking control test in 130 meter condition. As you see, this is Korea. The white line, the breadth of the white line is about 5 meters in scale, and red colored is real path trajectory of the mineral. If you can see the video, then the whole path can be followed very successfully, and at the same time, not only the path tracking, but also constant speed was controlled, was kept. It is 0.29 meter per second. We set 0.3 meter per second. It was fantastically good. We controlled the slip itself. Yeah, you are sorry? It doesn't work. This area was used for deep water test, and we call this area as mineral mound. originally we wanted to land in the depth of 1,000 meters over there, but the undulation was so severe and deeper. We went deeper. We came here. It was 1,370 meters. I'm very sorry. Yeah, last two slides. Safety and eco-friendliness is very important and profitable, I would like to say. By handling the technology development, we kept in mind eco-friendliness and safety to be profitable, not as a mandatory and not as a duty, but to be profitable. Minimize inevitable disturbance of the banking system and suppression and control of mass transfer from the bottom to the surface, except minerals, and reduction of carbon dioxide emission, and prevention of pipe clogging, and prevention of structural or machinery damages is major concern of safety. Based on this eco-friendliness and safety, much profitability is assured by saving the cost and sediment and water treatment on board, and pumping efficiency is higher, and downtime is reduced, so that the performance of minor robots might be maximized. The countermeasures to this environmental issue, we have put efforts to achieve the goal. By design of the optimum contact pressure, the mineral was successfully developed with assurance of flotation. Flotation means not to penetrate into the deep part, C4, and trafficability, enough driving force. And second topic, minimization of sediment transportation up to the surface. We tried to put a design idea to separate the sediments as much as possible at mineral robot and buffer station. And last but not least, flow assurance is quite important in the offshore industries for chemical mass transfer, but for also water and solid transportation. It is solid water, solid slurry transportation. If the nozzles are too much introduced into lifting pipe, then 5-kilometer long journey might cause unexpected problem. It is pipe clogging, and at the same time, if we can control the transportation rate in optimum condition for pump, then the energy consumption of the pumping system can be optimized. That means the CO2 emission is reduced. As a feeder control function was added as a buffer. The long journey to the technology development for over 20 years will be ended in the next year by Pumpy and Buffy Institute test. Pumpy and Buffy are nicknames of buffer and lifting pump. The buffer is in size so large compared with a person taller than me, and pump is 10 meter high. Yes, pump is 10 meter high. Total weight is 30 ton. It is almost same as OMI KSB lifting pump. Only the material is changed to resist the erosion. And the water depth not water depth. It's the buffer and pump. Buffy and pumpy will be installed about in depth of 500 meter to check the performance here. And water depths can be deeper. As mentioned by Thomas, this test can be categorized as pre-pilot mining test. The pilot mining test should be conducted in a total integrated way, together with miner robot, flexible link to the buffer, from buffer to the lifting surface, and if financial situation or financially it is available in the real CCFD area. However, if we have to limit the water depth shallower, then at least 2,000 meters, at least, is the question. The original plan of the Korean government was to finish the pilot mining test in 2015, but the goal has been changed a little bit. We have to finish the pre-pilot mining test of robot, buffer, and pump by 2015. But except total integrated mining test. Maybe ISA initiate such kind of big scale mining test in pilot scale. It will be very commonly beneficial for all contractors. Thank you very much.
Thank you very much. I'm impressed. Of the work you've done. I think that you are in the closest position to start real mining operations, perhaps. And I see that despite of high pressure, not only hydrostatic pressure, but the pressure for completing the work, you still have some fun of your operation. But I would like to ask maybe to comment about some development on future exploitation code. That I think that this document should consist of several parts, like e.g. legal regime and some taxation method and production rate and so on. But I see, of course, the need for something like some precise regulations of a technical nature, which should be included in that code, on characteristics of mining operation, like e.g. maximum discharge rate of deposit and of sediments, and we actually saw some station in your presentation on that. Is it possible you could comment how you determine those values, or maybe even it is possible to make it public on those rates and to discuss it, because I think that it can be a good basis for formulating and it will help the LTC for formulating future regulation on exploitation in this part of the regulations. Thank you.
Yeah, Thomas, it's a very important point you questioned. To quantify how much percentage of sediments are included in the slurry transportation up to the surface can be tried only through total mining test. Such a divided test is a principal test. Therefore, in the stage of the pre-pilot mining test, that is a componental subsystem test, then the qualitatively we can judge or decide the function and performance of the subsystems. All your points, how to quantify the sediment proportion of the mass transfer up to the surface, can only be conducted by large-scale integrated mining test. It is a very big challenge and important one.
Okay, thank you.
I have a few questions, but related questions. One, do you think, in your opinion, in your opinion, is it possible to transport nodule without crushing? Number one.
Yes.
It's possible.
Yes.
But don't you think the pipe size will be too unwieldy and the lifting pipe size will be too unwieldy for the total nodule? Because if the size is 10 centimeters, probably the size of the pipe will have to be, what, 200 millimeters, 300 millimeters? Or no, not much more. It is 10 centimeters. So
the mineral and the pump system is designed to be matched with the 8-inch inner diameter of the riser. 8-inch is 20 centimeters in diameter, inner diameter. And for commercial scale, it should be enlarged, of course.
Yeah, because if you have 10 centimeters, you should have a few times of that nodule size to size the piping, number one.
Yeah.
If you are crushing, what would be the kind of crushing size?
The design value of the crushed size of the nodule is to be 20 to 30 millimeters.
Minus. The last question. When you plan the upscaling to commercial size, will it be through multiplication of the, let's say, test mining size equipment, or it will be an enlargement of the size itself? Do I make it clear?
Not clear, I'm sorry. Yes.
When you go from 30 kph, 30 tons per hour test mining capacity to a commercial scale, will it be through multiplication of the 30 kph systems? That means 5 times 5 units, or you enlarge the size of the equipment, both the collector, the crusher, and the riser system.
I would like to say there is several alternative approaches. My preference is to expand such a unit robot, this lateral side expansion, by adding the modules. It has advantage, of course, disadvantage together. I can always stand by with the unit robot on board, and always repair and maintenance and much regular inspection is possible. And of course, to expand to the large commercial scale, each robot unit should be a little bit changed in size and length. However, such a concept might be efficient in my sense, in my opinion.
Last question. The shear strength measurement, was it done on the sediments collected from the corer on the board, or was it in situ test done?
On board.
On board.
Yeah. You collect the multiple samples and measured in on board.
Thank you.
Yeah.
Thank you.
Okay. Before the next questions, I would like to kindly remind you the main topic of our seminar, classification. This is very interesting, and we are very thankful for you. But please follow the main topic. Thank you very much. So who is next? First was Sandro, then Pedro, and then...
Yeah, going to the classification part. I just ran the parallel test for your sampling comparison of the spacing of your sampling as for the estimation of the resource. The n value you have, they are not comparable. The variance are completely different. So even if you both say 8.3 and 8.7,
comment or question?
No, I think I heard that you need to improve that. I think you need to.
Did you get?
No? No, for your estimation, right, it is crucial the spacing of the sampling, right?
Yeah.
And then you say that you did a low resolution, 14 kilometers, right, and then a high resolution at 3.6. You calculated your values for both, and it gave you 8.3 and 8.9, so it looks alike. But one, it was N, I don't know, less than 20, and the other was N 100. If I compare you put there the standard deviation in both of them, I transform that one to variance, and I run the test to see if I compare the variances of these two samplings, and they are not comparable. But my point is, if you increase the number of observations in the high resolution, I think, no, the lower resolution is where you have less number, right?
Yeah,
so you need to increase that every 14 kilometers, you need to increase your N in order to compare them. Otherwise they're not. Even though the average value, it was the same. It was 8.3 and 8.9, I think, plus minus something. Maybe you can show the slide.
But if they represent the same area, I thought the two values represented two different areas. One was a larger area, the other was a smaller area.
No, it's the same area.
It's the same area?
Yeah, same area, just the...
He compare 14 kilometers and high resolution, the 3.6.
The low density in at first times we take the sample in regular distance base, and at the times about the 15 kilometers, and in the same areas we choose our prospective areas, and there we choose to collect more samples in the same area. So we calculate the values and compare them, and there are the less than 5% difference in there. Yeah, so we need more works.
But then I have a question there, because your estimate is 8 point something plus minus 2.7, and that's the standard error.
Yeah.
Which would mean that the standard deviation must be very large.
Yeah.
I mean, from the data that we have looked at from the ISA geological model, it appears very unlikely that for an area of, let's say, 75,000 square kilometers, the standard deviation of abundance values will be anything significantly larger than 7. I have not seen values larger than 7, and if the value is 7, you can't have a standard error of 2.7. So that's my, confusion.
Okay, you may continue during.
Okay.
Yeah.
Thank you.
Okay.
Yes,
Okay.
What questions? Kendra and Jun.
Firstly, I wish to thank you very much for your presentations, as well as Thomas and Sander on behalf of Russian contractor. It is really fantastic to have this general overview of the pioneer investors during this period of work. Following the advice of Georgi, I just have a question. How would you classify your resources in terms of the preschool designation? And namely because, as far as I understood, you have collected nodules from 1,300 sites with 4 deployments at a site, but then you estimate resources only from 450 samples. How can you manage that in order to give a classifications in terms of resources?
Yes, the first times as you say about our strategy, at first time we increase the old sampling site is the 1,352 sites. So that includes our contract the whole areas, the 150,000 square kilometers. Among the half of them are in our contract areas, and some samples from there we estimate the mineral, the resources. You understand? So there are some difference in the in the sampling numbers and so it's the our calculation, our estimation, and our classification is not sure, but we just the make sure of our evenly spaced sampling base. So we showing the slide for the comparing of them. So just estimation, just the classification is the estimation. That we are not sure about the which categories the estimation or the classifications, but we could be enough samplings for the nodal estimations. Okay.
Yes.
Thank you for your presentation. I was really impressed by the progress you made, and I should express our congratulations on your progress. And maybe my question is similar to someone before. I just wonder that if you can, in general way, say something linkage between your plan for the future mining test with the classification of resources, as well as environmental impact assessment. I think that among these three fields, there's a very close link. Thank you.
As I mentioned in my presentation, one purpose of development of mineral was to use in the environmental impact in the CCFC and in resource assessment and classification, or the terminologies are a little bit strange, to count the mineable, to delineate the mineable area of Korea's contracted zone. We wanted to know how good could be the robot vehicles maneuvering on the seafloor, and depending on the maneuvering performance of the robot vehicle, we can delineate differently. That, in this sense, the mining technology might be linked together with resource classification or estimation, the mineable areas definition, and the mineable size, mineable amount of the nodules. In this sense, the mining technology should be integrated together with exploration data and put on your fields, geology, marine geologists. This is my understanding.
Okay, thank you, sir. But you see that we are very short in time, and unfortunately stop the discussion and continue during tea break. It will take us. It's not a question. It's not a question.
Question or comment?
No, it's a request.
Request?
Yes, you mentioned there that your models for building Pampi, Bafi, and Minero is HSE, right? Health, safety, and environment. My request is, if I understood everything, the three of them, Pampi, Bafi, and Minero, are tethered, right? So they are connected to both.
Yes.
Is there any possibility to withdraw a little bit of the energy of Pampi, Bafi, and Minero, and to put some environmental sensors like turbidity meters?
This is a question.
More like a quiz.
It's not good. It is not easy test. It is practically, yes, correct, yeah, possible. However, not work later.
Thank you very much.
We now have 3 more presentations, which will probably take lunch about 1 o'clock. So we've got time for the 3 presentations. The first one is on behalf of China Ocean Mineral Resources, and I'd like to introduce Mr. Jin to the presentation. Thank you.
I would like to take this opportunity to explain my sincere thanks to the Indian government and the American Institute and for inviting us to here. First time for me to be in India. And I feel it's a friendship and hospitality from India. And then I would like to thank Secretary of Civil Authority and the LTC and to organize this workshop, very important workshop. And then third, I would congratulate the form report from the other contractor. I was really impressed and should again explain my congratulations on the progress the other contractor made. And my topic is, I said that this is a topic pointed by the Secretary of the International Authorities. So I will focus on the harmless activities on resource assessment. First, I would like to show some features of harmless contractor area. It's located in the west margin of CC zone and consists of 2 main parts being 200 kilometers apart and spread 1,500 kilometers from east to west. That's a long distance. And the variable grade and abundance of nodules and even topography. And the deep water depths and the low grade in the west part and the lower abundance in the east part compared with some other contractor areas in city zone. So these are some features. And you can see some the topography in the east part and the west part. This is generally in the distribution frequency of nodule grade in the west part. And this is the distribution frequency of the nodule abundance also in the same part. Now, my presentation will focus on 3 aspects. One is commerce exploration strategy and the result. The second is the resource assessment or classification in commerce contractor area. And lastly, briefly, some suggestion for resource reserve classification. First is exploration strategy and result. And for us to implement this contract is for the purpose of assessment of resources and environmental impact on the site. This is one purpose. And then we will design all the test mining and the process systems. So today I will not talk about much about the environmental impact, environmental work, and the others. I will focus on the resource assessment. Then for resource assessment and exploration, we know that resource assessment combined with exploration at sea is a process of upgrading the nodule resources and the process of delineate a mine site. Then evaluate the quality, quantity, distribution, and economic value of the nodules in the contractor area. So this is some survey equipment we use in the contractor area. I will not show the details. I have a video, maybe about 30 minutes. I will show in the next time by the equipment, the geolo, and this equipment. So this is the 2 parts of the contractor area. This is the west part and the east part. The area total 75,000 square kilometers. And the block with the potential deposit we divided that the 6 in the east part of contracted area. This east part, this is 1, 2, 3, 4, 5, 6. And with the index for the abundance equal of 5 kilograms per square meters, and grade, and plus copper, cobalt, and nickel is 1.8, and the slope less than 5 degree. And 3 blocks in the west part of controlled area. So the main sample grade is 9.8 kilogram times 9.8 kilogram. In the west part, we have 783 sample station, and the east part have 849 sample station. And this is some work and density samples. This is the next step. We density sample in selected area for 3,000 square kilometers. And the sample grade is 7 times 7 kilometers. So this is selected area in the west part of contracted areas. The sample grade, the strategy is that from that the grade 9.8 kilogram, then we selected the areas 7 kilometer. Now from the 7 kilometer, we in more density samples in the 3.5 kilometers. So this is 1,800 square kilometer. So the sample station totally in this area is 1,173. So this is the east part for the last that 3.5 the interval kilometers. The sample station. So in the area from the 1,800 square kilometer, so we choose 217 square kilometers with flat period within these areas for the future environmental impact assessment together with in the future for some equipment testing. But this is our plan. So then the density sample and autonomous underwater vehicle measurement were carried out in this area. So this is the topography around the area for the future environmental impact assessment and equipment test. We carry out and will continue from 2013 to 2015 by AUV. This is the best bench in this specific area. So this is very briefly our exploration strategy and the result. And then the second, I will show some resources assessment and classifying cameras contracted area. First, we make some factors, the geologic factor we should consider. The area with a potential deposit, that tectonic features, topography, region, the structure type, and the feature of the surface sediment, and region reef structure. And then the deposit, distribution and coverage feature of the nodules, and lastly, all the type and the mineral feature of the nodules. Environmental factors, I don't want to read that, and just show some that we consider that, the factor we consider. Then all the commercial factor or market factors, investment and operating cost related to the collected recovery, transportation, processing of the nodules, variation of price for the metal possibly recovered from the nodule and the rate of return. This will consider the factors we make the resource assessment. And the main economic index to delimit area with potential deposit. I mentioned it before. So the result is that the classification in the west part of Kamara's contracted areas, area with potential deposit, we think that right now with this sample grade and categorize the resource, and then area with the dense examples, 3,000 square kilometers, this is great, and we identified, maybe indicate an area with future exploration, further exploration for these areas, and the grade is 3.5, and we think at this moment the major resources and the area for specific use, that's 217 square kilometers right now, and this is the grade. So this is the map we show the resource classification in the west part. And this is 3,000, and this is 1,800. And a small, in a small area, I could not find it. So the resource classification used by Kamara from the China, that the GT 1776 in 1999, based on the UNFC in 1997. So we provided the resources as measured, indicated, inferior. And I think at this moment, we just have such kind of categories of resources: 331, 332, and 333. So I think we can compare the resource classification between Kamara and Frisco. At this stage, we only get these categories, as I mentioned, and compare with the system of Frisco. And the last part, I just want to make some suggestion for the resource and reserve classification. And talk about the economic circumstances linked with the feasibility study. And I just want to show some, because the two universities very optimistic to predict the market, but the situation changed. We can see the last year that this is the nickel price get down. I think the same situation, the copper and the cobalt. I want to use that the Chinese Prime Minister, the government report this year. So in Chinese situation, we now is make economic structural improvement and upgrade. That in Prime Minister report, it mentioned that this year we will reduce outdated production capacity of the 27 million metric ton of steel. So I think that we talk about, the market perspective, that I just wanted that to show such information. And then I want to remind that the structure of seabed mining project from the report of the United Nations Expert Group in 1989. And we can see that all this, the first group of contractors still in this stage. And we are not in the feasibility study stage. I try to link it between the structure of seabed mining project and resource classification. I added one line, and the category of resource reserve. I think that the management, we will make decision to proceed. At this stage, I can say that pre-feasibility study, maybe in the stage of for pre-feasibility between R&D and feasibility study. So in this stage, maybe there's some 10 points from resources to reserves. Before that is the resources, after that is will be reserves. So this is, I try to make some linkage between these two. And then I want to remind, as early as 2006, the report from the LTC chairman that mentioned the consideration of proposal to establish mineral resources reserve classification system for the area. I just repeated that. The LTC noted that the need for classification for the area, but debate ensued as to the suitability for the resource reserved or the area of this existing system, which have been specifically designed to have a global applicability, for example, the UNFC. So I think the LTC, in very early, 8 years ago, they noted the necessity for this work. Lastly, I tried to make some suggestion proposal for the resource reserved classification, together with the exploration result. And first, we can see the water category we should have. Then the grade for exploration, and what kind of method and equipment we should use, and what's the exploration result, and mainly reflected by the map. This is really, it's easy to understand it, even for the member of state or authority. So this is very important. That's all. Thank you for your attention.
Yes, Ted.
Yes, thank you. In your talk, you mentioned the area that you've got reserved for future environmental impact work, and you also talked about potential feasibility study. I'm curious, do you have a proposed or anticipated schedule for when you expect to do your environmental impact studies and when you expect to conduct the feasibility, assuming that's the same as a pilot mining test? Do you know when you're going to do those?
Okay. We try, the Cabinet try our best to persuade the government and to have support, financial support. We propose a program for the mining system test. But every time I talk to the people in the government, they will always raise one question. Can I explain when people can see the perspective for the time for the commercial mining? So that's a problem. Now we still try our best to persuade the government to put the money. And right now, maybe I can say that we're still in the process of procedures. But I hope that with the progress made by other contractors like Korea, I'm more confident to get support from the relevant department to such a program.
I don't think so.
That's we try to do that. And our plan is that because we know that without a pilot test, it's very difficult to make the resource assessment or classification and the environmental impact assessment. Yeah.
Any other questions? Yes.
I think it's important that I want to acknowledge the fact that I think we have been hearing this 2 days. I think your presentation is direct to the subject, for which we all have assembled here in Goa. And actually, I'm impressed by your presentation. I don't have anything to ask you except to say that you have done an excellent job through this presentation. I'm sure that I think it will invoke, ideas into our minds. Thank you.
Thank you. Ted.
Just one quick follow-up question. With the problems or the anticipated problems you have getting money from the government to conduct some of these follow-on works that you want to do, do you think COMRA would have interest, as maybe was suggested earlier today, I think by Tomas, of maybe combining with other contractors to conduct some type of a joint pilot mining test?
My answer is certainly, because we are trying, for a long time, the cooperation between the different groups. Now, even China, except get the support from government, we also discuss the possibility for enterprise. Even now in China, there's many even private enterprise. If they are interested, we can get another source of support. And also, I believe that international cooperation is very important. So this is we always, encourage and the authority to play the role, to use all the resources together and have some program and maybe use this specific capability from the individual maybe entities and others. So I'm confident in that. Thank you.
Thank you. Any other questions? Okay, well, thank you very much.
Thank you.
Very good presentation. The next presentation is on behalf of the Deep Ocean Resources Development Company.
Okay, thank you very much. It's been really to be here to see many people working same things and good preparation ASA people and also good hospitality of Indian people here in Goa is really appreciated. So I can concentrate to the resource evaluation as George's suggestion. That is the first one. Yes, this is the title. Then, okay, resource classification and evaluation. At first, we must have a mineral resource with a certain level of accuracy to start feasibility studies. So then, based on the mineral resources, economic viability and not many things are considered for the feasibility study. Then, I know we also must convince the investors that the mining operation will be profitable. And at first, we must have mineral resources with a certain level of, okay, same thing, so level of the accuracy to start the feasibility studies. Then, oh, I'm sorry, this is the same one. No. Yes. Yes, this one. You saw it many times yesterday, but I just want to refresh ideas based on, this is based on my talk. So geology, mineral resources. So see the exploration result here, and we increase the level of geological knowledge, then we confidence increase in the mineral resources. First infer the mineral resource, then indicate and measure. Then after getting indicate resources or measure, then we consider the modifying factor. Is probably, I think it's not so much different from feasibility studies. Then it's a profitable, then we call it reserves. And not, the answer no, then we must go back again and stay here as a resource. It's the same thing, I'm just showing the diagram. So indicate mineral resources and measure mineral resources, then modifying factors. So we have four reserves. And so see, everybody now has not reserves but the mineral resources. And then let's see the definition of the mineral resources based on the JORC. It's only written in the words. There's no numbers, things classifying this. So for example, inferred mineral resources, it's a low level of confidence, and indicated mineral resources, reasonable level of confidence, and high level of confidence for the measured mineral resources. So only they are decided only by the competent person. Yes, so that's the classification. There are no critical numbers for separating these classification. Yes, I also expected that this UNFC classification is coming up. Then we should probably sometime we must decide whether we should follow JRC or United Nations framework classification. I just made a comparison, but essentially this classification introduced to the Eastern European countries. So I have experience. I put the name of country here in Albania. This is representing Eastern European countries. They have this classification. So that input indicates major resource, but they do not have a modification factor or say a feasibility study. So then they never get, these never becomes reserves. It just only stay in resources. So then JRC has a resource here. Then after modification factor, there will be reserves. But essentially it's the same thing here in UNFC. The difference is that only during the mineral resources they have some sort of the economic variability and the feasibility here. So the first numbers and the second number represent these things. But here we don't care about it. Then only after the modification factor that it will be economically examined. So then I think for me it's much more just accustomed to it and also much clearer. So yes or no, then stay in reserve or resource, or then go up to the reserve. Then now we must see, this is essentially based on one situation. So we must think about the polymetallic nodule. Polymetallic nodule a little bit different from other type of minerals. So then on one situation, therefore, cannot directly be applied to polymetallic nodule. The difference is that different from the on-run situation, the polymetallic nodule, we can consider the two-dimensional distribution. Some of the nodule is buried inside the sodium sediment, but normally, mostly, it's only the surface. So then we can treat it by two-dimensional distribution. And vast distribution scale, that's huge area we must consider. It's also different from the on-run situation. And also small variation in ore grade. So then we use the abundance for drawing contour lines, but in on-run situation we use the contour line of the grade, copper and gold and something like that. And next thing is covered by water, but mostly exposed on the surface of the seabed. So then in that case we should better make full use of the photograph and the videos. And the other thing that a little bit different from the situation in polymetallic nodule and on-land is on-land mines, you must make a huge structure like this for the facilities, say, of open pit mines and underground mines. There's many additives in the underground. So they need a lot of money to make this. But polymetallic nodule, you need a ore collector, then a mine vessel, and connected by this riser pipe. So after finishing one place, you can move anywhere you want. But in this case, you must stay there whole mining operation period. That makes a big difference. And so now, based on this thing, I'm going to talk about our situation. So it's the same as everybody. We have exploration license areas of 75,000 square kilometers. Then from that, we made areas called first generation mining areas. In another word, we call it high abundance area. It's approximately 6,000 square kilometers. Why 6,000 square kilometers? For the pre-feasibility studies conducting for the area with about 20 years mining operation. Usually we, on one situation, well probably I think it's applicable to the metallic nodule, but we must think about a certain period to do the pre-feasibility study. So then I took 20 years for that period. And then if the average abundance is 10 kilograms per square meter and annual production rate 3 million, that makes 10,000 tons per day times 300 working days, then coverage is about 3 square kilometer per year. Then 300 square kilometer per kilometer times 20 years, that makes 6,000. That's why 6,000 is from. And also 3 million per year. We sort of did a preliminary economic or preliminary economic analysis. And first we started from the 1.5 million ton per year, but it was not feasible. Then at the 3 million ton per year makes a lot of better results. So then we just setting the 3 million ton per year. And then in addition to this, this is still a huge area. So then we made a model area for detailed survey. The idea is that it's now about 80 square kilometer per 80 square kilometer at present. The idea is that we use the AUV survey for the detailed survey and conduct it for the understanding of the nature of the nodule distribution and detailed topography. And so the result is fed back to the high abundance area of 6,000, or probably you can say that the extrapolation method. So, okay, I'll show you our area of the license. Here is the one in the west area, and then the other one in the east area, in the Creek zone. Well, it's a quite big, huge area compared to the on-land situation. But in square shape, 274 kilometers times 274 kilometers is quite huge. And this is sampling location of the west area. It was done during pioneer investors, mostly based on free-fall blood sampling. Free-fall blood sampling, something like this. There was a sampling station here. Then we take sampling at 3 locations. Then average value we use for this. And free-fall blood is poor sampling. It's not, we can't collect whole samples there. Then we took a photograph, and mostly we use the photograph data for the abundance. And this is about, so this is the west area, and then we select somewhere here for the high abundance area. Yes, this is high abundance area. In other words, you can say that, first generation of mines area. About, as I told you, about it's approximately 6,000 square kilometers, then more than 10 kilograms per square meters of the abundance here. Using the sample of the free-fall blood that you saw a little bit before, we have sample like this. This is points we made using kriging and constructed the abundance map. The abundance map is so complicated. Actually, there are not many sampling locations. Go up and down. Sampling location, something here, here, here. And probably I think this is the situation for the mineral resources. Then we have other data. This one, CDC, continuous deep sea camera. This is a different from deep tow camera, but this one is camera go up and down, and then we just keep towing. So then one survey we can continue all the way about 50 kilometers like this. So each camera location is about 50 kilometers apart. So we have a free photograph sampling, and in addition to them, we add this CDC data, but it's only from the photographs. So then we draw again an abundance map. Now it's getting much clear. All the contour lines nicely drawn, but still this CDC interval is a few kilometers, but between the lines we have about more than 10 kilometers apart. So comparing the two results only for FG and then FG plus CDC, this one here is we get much higher zone appears, but in this area much lower zone appears. But anyway, this is different, much clear figures this. So then this is comparison map. The yellow one part is the same as this one, same compared with this one, same. But the red one getting high, part of getting higher, the blue one getting lower, and resource calculation conducted using conducted, and then if we say 100% for this, then it becomes 94.4%. So then, yes, so that's what we have here. But then still, I don't know whether this can be the indicated resource or still stay in the inference status. Okay, then I'd like to change the topics now. This is topographic feature. You can see all the distribution slope gradients. This yellow one, it's maximum 5 degrees. So then yellow, this yellowish green, and blue is less than 5 degree. Slope is 5 degree. Yes, but if it gets more than 5 degree, I found that on the video and the camera, we found this kind of topographic step. So then it's very tough for the mining machine to move around. So then it's now at this moment, I'm thinking that the area is supposed to be less than 5 degree. Okay, the physical minor resources. So minor resources are, I told you the area slope gradient less than 5 degree, and also I decided the numbers cutoff grade at 7.5 kilograms per square meters. Then all the areas average going to be 12.31 kilograms per square meters. So this area is going to be 92.5% of the total area, total mineral resources is mineable. So the one that only drawn by the FG is inferred mineral resources, but the FG plus CDC is indicate resource, or I don't know, maybe only the competent person knows, but for my understanding, I think it's still a little bit slightly less than indicate resource. Then we must improve the result data. So this is one of the ways that we are trying to improve the resource to be the indicate the resources. Increasing accuracy of the mineral resources to indicate rock level. First, we conducted detailed survey in the model area, so feedback will result to the high abundance area. And so we have, and also we must understanding the continuity of nodule distribution and the possible relation of the nodule distribution to the topography. And also we must need a statistical treatment of the data and understanding accuracy, particularly the photographs. And also we need to determine the proper the proper sampling interval for indicated results by the statistical treatment, such as using the expected value and the degree of the confidence. So then, after considering this, we can probably get some number for the supplemented data collection in the high abundance area. Or probably by the box scorer and seafloor photographs. So this is a model area. Now it's about 80 square kilometers. We use the AUV, so this north-south trending zigzag is connected by the AUV types, and also for the topographical survey, then this black straight line is the camera line. We took a continuous photograph of the seabed.
5 minutes.
5 minutes, okay. Okay, this is a topograph that we got from AUV survey as one grid data and 2 meter interval. We can see the very clear photographs of seafloor situation, and also the this is a gradient, slope gradient map from this. The area is generally flat, although there are many contour lines, but the area is flat. But only this area, there's some steep slope here. And this is the continuous photographs. And from photographs, we get all the information by the image analysis, event coverage, and major axis, and number of the nodule. So then we calculated from this, we got abundance here by the empirical equation. This is the topographic section. This is, of course, it's exaggerated, and this is the hill area, and then lowland area. The lowland area is abundance becomes less than 10 and rather low compared with other areas. This is one of the statistical treatment trial. We set the intervals of sampling. We have many photographs, but now we set the interval photographs, interval of these. For example, this is 250 meter, and then changing 500 and 1,000, 1,500. Then this is one interval here. Then we took out one sample from here. Then next here, here, and then here, changing the location of taking out samples. Then we did some statistical analysis. So this is a result of statistical analysis. This shows that after the interval becomes more than 1,500, it's all spread out. So then I think our sampling grade or data grade better to be less than 1,500. So then, for the increasing the accuracy of mineral resources, statistical treatment of data and understanding of accuracy, particularly photography, is necessary. So accuracy of the location of all the sampling must be also qualified, particularly the free-form lab, CDC, the box score. Some of them are done, very long years ago. Then location is not so good. So we must, if we're going to use this data, we must be qualified the errors, and also accuracy of the photograph data. That means that the image analysis to obtain the coverage, image analysis, and number of nodules. We have an empirical equation using these data. So then we decide the abundance. But it may depend on the type of nodule. I mean, empirical equation differ from the type of nodule. So in that case, we must getting more samples for clarifying this equation and understanding the distribution potential and its continuity of the nodule by standard statistical treatment necessary. And in that case, I showed you one of the examples showed that less than 1.5 kilometers. Okay, now, then, using these factors, we're going to decide the in-field data collection interval for the box score and sampling, box score sampling and photograph taking. So this is the situation now, and we're going to do the. Yes, we're going to do the sampling to, in-field sampling, place somewhere this, So my conclusion is the mineral resources we have now is more than an inferred category, but seem to be not enough accuracy for the indicated category. So then statistical treatment of these data is necessary to decide the good sampling interval for the indicated resources. So then we're going to do the in-field data collection by box score and photograph taking. Yeah, that's all.